Good morning everyone, welcome to paragraph 7.3. In today's episode I will continue my talk about factorization. This time we will use it to turn a trinomial into a binomial. A word of warning, be sure to practice what I'm about to teach you, as this is fundamental for the rest of the chapter. With that being said, let me teach you about the product sum method. Just as in the last paragraph, let me start with some exercises from the past. In chapter 1, I taught you how to simplify an expression by multiplying out the brackets of a binomial. For example, to simplify x plus 4, x plus 5, you would need to multiply each term with the other brackets term. To visualize, I use these arches. X times x times 5, 4 times x, and 4 times 5. So we got x squared plus 5x plus 4x plus 20, which could be simplified one more time into x squared plus 9x plus 20. To understand what the product sum method is, let's do a few more exercises, with the last one, x plus 3, x plus 4, being my favorite binomial. Were I to simplify these binomials with the arches, I would receive these intermediate steps. I can then simplify them one more time. These intermediate steps can actually be skipped if you know a special trick. Take a look at the numbers from our results. Notice anything special? If you've noticed that the middle number is the sum of the two terms, and the last number is the product of the two, then congrats, your eyes work just fine. So the binomial x plus 10, x plus 8 turns into x squared plus 18x plus 80, and x minus 9, x minus 2 becomes x squared minus 11x plus 18. We are going to use this trick to factorize our binomials into trinomials. So we start with x squared plus 8x plus 12, and we want to turn it into something like this. To do this, we use the product sum method. We need to find two numbers where the product is 12 and the sum is 8. Without much effort, we find 2 and 6. So x squared plus 8x plus 12 turns into x plus 2, x plus 6. And just so you know, if you write down x plus 6, x plus 2, that's fine. Now we factorize x squared plus 9x plus 20. We're looking for two numbers that are multiplied 20 and added 9. Those two numbers are 4 and 5. So we turn our trinomial into the binomial x plus 4, x plus 5. Next one is x squared plus 14x plus 24. To factorize this, I want it to look something like this, with two numbers inside the brackets. Multiplied, these numbers should be 24. Added, they should give me 14. The only possibility here is 2 and 12. So our new binomial is x plus 2, x plus 12. To factorize x squared minus 12x plus 20, we need to find two numbers that are multiplied 20 and added minus 12. The only two that match that description are minus 2 and minus 10, as negative times negative becomes positive. So we receive x minus 2, x minus 10. And to factorize x squared plus x minus 20, we have to look for two numbers that are multiplied minus 20 and added must give us a plus 1, as this is the hidden number in front of the x. If you have trouble figuring out which numbers are correct, you can make use of a cheat table. A cheat table is a small table with every possible combination of the product number, so in our case minus 20. We can make minus 20 with 1 times minus 20, minus 1 times 20, 2 times minus 10, minus 2 times 10, 4 times minus 5, and minus 4 times 5. We won't be using decimal numbers in this chapter, so you don't have to write down things like 0.5 times minus 40. When finished with the table, we're going to check for the sum of each combination. 1 and minus 20 give me minus 19. Minus 1 and 20 is 19. 2 and minus 10 is minus 8. Minus 2 and 10 is 8. 4 and minus 5 become minus 1. And minus 4 and 5 are added 1. We were looking for a sum of plus 1, so that means that minus 4 and 5 are the correct numbers. So x squared plus x minus 20 becomes x minus 4, x plus 5. Or x plus 5, x minus 4. That's also fine. But do not write it as x minus 5, x plus 4, because that gives me a minus 1 for the sum. Ready for some more? Then here are a bunch of trinomials I want you to turn into a binomial with the product sum method. Pause the video if you want to give it a try and stick around for the answers. And these are the answers. Did you make a mistake? Then keep practicing with the exercises in the book. Did you have them all correct? Good job! Keep practicing with the exercises in the book. Part 2 of this episode is a summary of the rules of factorizing. With the product sum method in hand, we now have 3 different ways to factorize quadratic expressions. The first is to check whether there's a common factor between the terms. 18x squared plus 42x share a factor of 6x, so we put that in front of the brackets. We receive 6x, 3x plus 7. Secondly is the product sum method, which you just learned. So x squared plus 3x minus 4 becomes x minus 1, x plus 4. The third method is the difference of two squares. 4x squared minus 25 becomes 2x plus 5, 2x minus 5. A combination of the three is also possible. For example, 3x to the power of 3 plus 15x to the power of 2 minus 42x. As every term contains the factor 3x, we take that out of the brackets. We now have the line 3x, x squared plus 5x minus 14. The inside can be factorized by using the product sum method. We end up with 3x, x minus 2, x plus 7. So be sure to look closely on what you have to do to completely factorize an expression. The final part of this paragraph is all about proving number properties. This part is somewhat of an advanced skill level, so you better pay attention. You see, using factorizing, you can prove certain properties when working with numbers. One such thing we can prove is whether a number or series of numbers is odd or even. As every odd number can be written in a 2n plus 1 form, and every even number in a 2n form, with n being a natural number, we can see from the form if our answer is odd or even. For example, we can prove that the sum of 4 consecutive numbers is always even. So let the first number be x. The next number will then be x plus 1. The third number will be x plus 2, and the last number will then be x plus 3. The sum can be written as x plus 1 plus x plus 2 plus x plus 3, which can be simplified into 4x plus 6. By factorizing this into 2x plus 3, we can compare it with the 2n form. The part within the brackets will be a natural number, so this can be written as an n, and that means that sum of 4 consecutive numbers will always be even. The last proof I will show you here is the proof that my own math teacher taught me to quickly calculate the square of a number that ends with a 5. So 15 squared, 25 squared and 75 squared. These numbers can be written in the form 10n plus 5. For 5, the n would be 0, as 10 times 0 plus 5 is 5. For 15, the n would be 1, as 10 times 1 plus 5 is 15. The square of this form is 10n plus 5 squared, which can be simplified to 100n squared plus 100n plus 25. By factorizing the first two terms, we can turn this into 100 n plus 1 plus 25. With some smart deduction, this is where the trick comes into play. This part of the expression means that I can take the digit in front of the 5 and multiply that with the next natural number, so 2 times 3 or 7 times 8. We then place this product in front of a 25 from the expression. So, to quickly calculate the square of 35, just multiply the 3 and its consecutive 4 to receive 12. Place the 25 behind it and you receive 1225 as your answer. And the square of 8.5 is 72.25, because 8 times 9 is 72. And with that, we've reached the end of this paragraph. In the next paragraph, we'll be using the knowledge of factorization to solve quadratic equations that aren't in the form x squared is c. Be sure to practice enough on how to factorize expressions, because without it, you won't be able to make any exercises going forward. I hope to see you in the next episode. Bye bye!